prepare to embark on an extraordinary journey aboard two of the U.S. Navy's greatest aircraft carriers, the USS Gerald R. Ford and the USS Nimitz. These colossal ships, while from different eras, showcase the unmatched power, innovation, and legacy of American naval engineering. First, we delve into the USS Gerald R. Ford, the most advanced aircraft carrier ever built. Commissioned in 2017, it is the flagship of a new generation of carriers designed to redefine naval warfare. Featuring groundbreaking technologies like the electromagnetic aircraft launch system and advanced nuclear reactors with 3 times the power output of its predecessors, the Ford is built to tackle the challenges of the 21st century and beyond. Its improved flight deck efficiency and cutting-edge systems allow it to launch more sorties per day, keeping it ahead of any adversary. Next, we turn to the USS Nimitz, the oldest active carrier in the U.S. Navy. Commissioned in 1975, it has earned its place in history as a true workhorse, supporting decades of missions around the globe. Its robust design and steam-powered catapults laid the foundation for modern supercarriers. Even today, it continues to serve with unwavering reliability, embodying the strength and resilience of the U.S. Navy. Despite the differences in their technology and design, the USS Gerald R. Ford and the USS Nimitz share a common purpose: to project power, safeguard freedom, and provide a home to the dedicated sailors who serve aboard them. In this video, we'll explore the groundbreaking advancements of the USS Gerald R. Ford and the enduring legacy of the US Nimitz through exclusive documentaries. Join us as we uncover what makes these carriers the ultimate symbols of American naval superiority. As the lead ship of the Ford-class carriers, this supercarrier marks a significant departure from previous designs, incorporating cutting-edge technology, enhanced capabilities, and improved operational efficiency. Named after the 38th President of the United States, Gerald R. Ford, this nuclear-powered behemoth represents the culmination of decades of naval engineering and technological progress. Its purpose is to ensure that the U.S. Navy remains unmatched on the global stage, both in terms of military might and technological prowess. The USS Gerald R. Ford is designed not only to project power across the globe, but also to adapt to the evolving challenges of modern warfare. With the ever-increasing complexity of international conflicts, maritime security, and the rise of peer adversaries, this carrier is a crucial asset in maintaining U.S. naval dominance well into the 21st century. In this video, we will dive deep into the ship's fascinating features, exploring its size, technological innovations, costs, and the revolutionary systems like emails that make it a marvel of modern engineering. At over 1,106 feet long and 256 feet wide, the USS Gerald R. Ford is a colossus. Its flight deck is vast, covering over 4.5 acres, and is capable of launching and recovering multiple aircraft simultaneously. For perspective, that's roughly the size of 4 football fields, making it a floating city with a crew size that rivals a small town. The ship has a displacement of about 100,000 tons, meaning it can carry an enormous amount of weight, including aircraft, fuel, munitions, and provisions to sustain its crew during long deployments. The ship's size alone makes it an imposing presence on the world's oceans, but its design is what truly sets it apart. One of the key differences between the Ford-class and its predecessors, the Nimitz-class, is the significant reduction in crew size. While the Nimitz-class carriers require over 5,000 personnel to operate, the Gerald R. Ford operates with a crew of around 4,500, thanks to enhanced automation, improved technologies, and a more efficient layout. Beyond the massive flight deck, the internal structure of the ship is equally impressive. The hangar bay, where aircraft are stored and maintained, is larger and more efficiently organized than on older carriers, allowing for quicker aircraft preparation times. This efficiency extends to other areas of the ship, including its storage for munitions, fuel, and spare parts, all of which are optimized for rapid access. This focus on efficiency means that the Gerald R. Ford can operate more effectively and for longer periods without needing to return to port for resupply. The design also incorporates greater survivability features. The ship is constructed to better withstand damage from modern threats, including missile attacks and underwater explosions. Its hull is reinforced, and critical systems are hardened to ensure that the ship can continue operating even under extreme combat conditions. The USS Gerald R. Ford is often described as a technological revolution at sea, and with good reason. It boasts several advanced systems that are unprecedented in naval history. These innovations make it more capable, efficient, and lethal than any aircraft carrier that has come before it. One of the most important innovations is the Electromagnetic Aircraft Launch System, EMALS, which we will explore in detail later. EMALS allows for more efficient, reliable, and flexible aircraft launches, significantly improving the ship's sortie generation rate, or how quickly it can launch and recover aircraft. This is a game changer for naval aviation, as it reduces the time aircraft spend on the deck and increases the overall operational tempo. The ship is also equipped with advanced arresting gear, a system that replaces the traditional hydraulic systems used for catching aircraft upon landing. AAG offers more precise control, making it possible to land a wider variety of aircraft safely, including unmanned aerial vehicles and lighter planes, which would be difficult to recover using older systems. This flexibility ensures that the Ford can handle both current and future airframes, including drones and next-generation fighters. Another critical feature of the Ford class is its dual-band radar. Unlike previous carriers that needed separate radar systems for air search and missile guidance, the Ford's DBR combines both functions into a single system, reducing the radar's footprint and improving its overall effectiveness. This cutting-edge radar can track multiple targets across various ranges, from incoming missiles to enemy aircraft, and can prioritize threats in real time. One of the less glamorous but equally important innovations on the USS Gerald R. Ford is its improved weapons elevators. These elevators use electromagnetic motors to transport munitions from the magazine to the flight deck more quickly and reliably than traditional elevators. The result is a more streamlined process for loading aircraft with weapons, further enhancing the ship's combat readiness. In terms of defensive capabilities, the Gerald R. Ford is equipped with integrated self-defense systems, including missile interceptors and close-in weapon systems. These systems provide multiple layers of defense against incoming threats, making the Ford more resilient in hostile environments. At the heart of the USS Gerald R. Ford's capabilities lies its nuclear power plant. The ship is powered by two newly designed A-1B nuclear reactors, which provide a combined total of nearly 600 megawatts of electrical power. This is almost triple the power of the Nimitz-class carriers, which allows the Ford to operate its advanced systems, including EMALS and DBR, without straining its power grid. The use of nuclear power gives the Ford-class carriers virtually unlimited range, as they do not need to refuel for over 20 to 25 years. This is a significant advantage in terms of operational readiness and global reach. The ability to stay at sea for extended periods without needing to return to port for refueling means the ship can remain in contested or strategic areas longer, providing a constant show of force or deterrence. In addition to providing more power, the new reactors are also more efficient and easier to maintain. The reduced need for maintenance allows for more time at sea, while the increased power output supports future systems that may require even more energy, such as directed energy weapons or advanced sensor arrays. Another benefit of nuclear propulsion is the Ford's higher speed. Although the exact top speed of the Gerald R. Ford is classified, it is believed to exceed 30 knots, around 35 miles per hour, allowing the carrier to quickly reposition itself in response to emerging threats or to outrun potential adversaries. This agility, combined with the ship's operational endurance, makes it a formidable asset in any naval fleet. The USS Gerald R. Ford is undoubtedly one of the most expensive warships ever built. The total cost of constructing the carrier is estimated to be around $13 billion. This figure does not include the additional $4.7 billion spent on research, development, and testing of new systems like emails and AAG. When considering the entire Ford-class program, including subsequent ships in the class, the total cost is expected to exceed $37 billion. While this price tag might seem astronomical, it's important to recognize the long-term benefits and cost savings that the Ford-class carriers are designed to deliver. For instance, the significant reduction in crew size means lower personnel costs over the ship's 50-year lifespan. Additionally, the use of more efficient technologies like emails and AAG reduces maintenance costs and increases operational availability. The Ford-class carriers are also expected to remain operational for over half a century, providing decades of service to the U.S. Navy. This longevity, combined with the ship's advanced capabilities, makes the investment in the Gerald R. Ford a critical part of maintaining the Navy's global dominance. In terms of cost efficiency, it's also worth noting that many of the systems developed for the Ford-class carriers, such as emails and AAG, will be integrated into future naval vessels, spreading the cost of development across multiple platforms. This approach ensures that the technological advances pioneered by the Gerald R. Ford will benefit the Navy for decades to come. The Electromagnetic Aircraft Launch System, EMALS, is one of the most groundbreaking technologies on the USS Gerald R. Ford. Traditional aircraft carriers use steam-powered catapults to launch planes, a system that has been in use since the 1950s. While effective, steam catapults are bulky, require extensive maintenance, and are limited in terms of the types of aircraft they can launch. EMALS, on the other hand, uses electromagnetic energy to launch aircraft, providing a smoother and more controlled acceleration. This system is 30% more efficient than steam catapults, meaning that the Ford can launch more aircraft in less time, dramatically increasing its sortie rate. The smoother acceleration provided by EMALS also puts less stress on the aircraft, reducing wear and tear and extending the operational life of the planes. One of the key advantages of EMALS is its flexibility. Unlike steam catapults, which are best suited for launching heavier aircraft, EMALS can launch a wider range of planes, including lightweight unmanned aerial vehicles. This adaptability is critical as the Navy begins to incorporate more UAVs into its operations, particularly for reconnaissance and combat missions. Another significant benefit of EMALS is its lower maintenance requirements. Steam catapults require a large crew to operate and maintain, and their complex machinery is prone to breakdowns. EMALS, by contrast, is far simpler and requires fewer personnel to maintain, reducing both the operational workload and the risk of system failures. While EMALS has faced some technical challenges during its development and early deployment, the system is now fully operational and represents a major leap forward in naval aviation. It is expected that all future U.S. Navy aircraft carriers will be equipped with EMALS, solidifying its role as the new standard for aircraft launches at sea. One of the most remarkable aspects of the USS Gerald R. Ford is that it is not just built for today's naval operations. It is designed to remain relevant well into the future. The ship is equipped with space, power and cooling capacity to support future technologies that have yet to be fully developed or deployed. For instance, the Ford is expected to be one of the first platforms to field directed energy weapons, such as laser systems capable of shooting down incoming missiles or aircraft. These weapons, which require vast amounts of electrical power, will be well supported by the Ford's robust nuclear reactors. The carrier's advanced weapons elevators are another feature that points to the future. These elevators, which use electromagnetic motors rather than cables, are faster, more reliable, and capable of moving heavier loads than older systems. This means that the ship can more quickly arm its aircraft, improving its overall combat readiness. Additionally, the Gerald R. Ford is well suited for the integration of unmanned systems, both aerial and underwater. The ship's advanced flight deck systems, including EMALS and AAG, can handle a wide variety of airframes, from traditional manned fighters like the F-35C to next-generation UAVs. This flexibility ensures that the Ford will remain a vital asset as the nature of naval warfare evolves. The ship is also designed to be modular, meaning that as new technologies become available, they can be more easily integrated into the Ford systems without requiring extensive retrofitting. This future-proof design philosophy ensures that the Ford will remain at the cutting edge of naval technology throughout its service life. Life aboard the USS Gerald R. Ford is designed to be more efficient and comfortable than on previous carriers. The ship's reduced crew size, made possible by greater automation, means less crowding and more space for each sailor. In addition to improved living quarters, the ship offers expanded recreation spaces and better facilities, including a larger gym, more dining options, and enhanced communication systems to keep sailors connected with loved ones back home. One of the key goals in designing the Ford-class carriers was to reduce the workload on sailors. Automation plays a significant role in this, with many routine tasks now handled by machines rather than manual labor. For example, the ship's advanced weapons elevators require fewer personnel to operate, freeing up sailors for other duties. This not only makes life easier for the crew, but also increases the ship's overall efficiency. The Gerald R. Ford also offers improved medical facilities, ensuring that sailors receive top-notch healthcare while deployed. The ship's hospital is equipped with modern medical technology, including advanced diagnostic tools and surgical facilities, allowing it to handle a wide range of medical emergencies. Overall, the living conditions on the Gerald R. Ford represent a significant improvement over previous carriers, reflecting the Navy's commitment to improving the quality of life for its sailors. The USS Gerald R. Ford is not just a new ship, it is a game changer for naval operations. Its advanced systems allow it to operate more efficiently and effectively than any previous carrier, giving the U.S. Navy a significant advantage in both peacetime and combat operations. The Ford's increased sortie rate means that it can launch more aircraft in less time, allowing it to respond more quickly to emerging threats. This is particularly important in modern naval warfare, where speed and flexibility are critical to success. The ship's enhanced power generation also means that it is well suited for the future of naval warfare. As directed energy weapons and advanced sensors become more commonplace, the Ford's nuclear reactors will provide the necessary power to support these systems, ensuring that the ship remains at the cutting edge of military technology. In terms of global reach, the Ford's nuclear propulsion gives it the ability to operate anywhere in the world for extended periods without needing to refuel. This makes it a key asset in the Navy's ability to project power across the globe. In 1975, from the Western Pacific, the USS Nimitz stands as the first of the Nimitz-class supercarriers. The USS Gerald R. Ford, 10 nuclear-powered aircraft carriers is a monumental achievement in naval engineering and military technology. Over the course of nearly the most advanced aircraft carrier in the world, Nimitz has cemented designed to not only meet the challenges of active aircraft but to remain relevant for decades to come. Its enduring design, with its revolutionary systems like modern naval warfare, nuclear propulsion, as the most experienced aircraft carrier in the U.S. Navy, Gerald R. Ford, the Nimitz has participated in nearly every significant naval operation of the past as the flagship of the U.S. Navy's Cold War class Operation Desert Storm, the USS Gerald R. to the global war on terror and present-day deterrence missions. U.S. USS Nimitz has proven to be an essential asset to American military power. To American ingenuity and a symbol at the heart of the USS Nimitz's reputation is its longevity. It holds the title of the oldest active aircraft carrier. The Gerald R. Ford Navy stands with an extraordinary challenges of the 21st century. It was named after ensuring that the U.S. Navy remains the most powerful maritime force in the Pacific Fleet during Second World War. And that concludes our video on the USS Gerald R. in the Pacific Theater. The most advanced aircraft carrier in the U.S. service life is a remarkable achievement for an aircraft carrier, particularly one involved in such extensive and varied operations. To put it into perspective, when the Nimitz was commissioned in 1975, the Cold War was still ongoing, the Vietnam War had just ended, and many of the systems and technologies that are commonplace today were either in their infancy or yet to be developed. The fact that this ship remains one of the most capable carriers in the world speaks volumes about the foresight of its design and the continuous upgrades it has received over the years. One of the primary reasons for the Nimitz's long service life is the nuclear propulsion system, which enables the carrier to operate for over 20 years without refueling. This has allowed the Nimitz to deploy for extended periods, providing a sustained presence in key strategic areas around the globe. The USS Nimitz is truly a floating city, measuring approximately 1,092 feet in length with a displacement of over 100,000 tons. The carrier is one of the largest warships in the world. Its size enables it to carry a formidable air wing, consisting of up to 90 aircraft, including FA-18 Hornets, Super Hornets, EA-18G Growlers, E-2C Hawkeyes, and MH-60R Seahawk helicopters. At the heart of the ship's capabilities is its nuclear-powered propulsion system, consisting of two A4W nuclear reactors, allowing it to cruise at speeds exceeding 30 knots, approximately 35 miles per hour. These reactors provide an immense amount of power, not only to propel the ship, but to support all onboard systems, including the complex radar and electronic warfare suites, the catapults for launching aircraft, and the powerful systems that make the ship one of the most feared weapons platforms in the world. Additionally, the Nimitz is equipped with 3 catapults and an angled flight deck, which allows for continuous flight operations, with aircraft taking off and landing simultaneously. It is also equipped with advanced radar, navigation, and communication systems, making it one of the most technologically advanced vessels in the U.S. fleet, even after nearly 5 decades of service. Life aboard the USS Nimitz is unique. With a crew of nearly 5,000 sailors, including the air wing, the carrier functions like a small city. Sailors on board engage in a variety of jobs, from maintaining the ship's nuclear reactors to handling aircraft operations and everything in between. Daily life on the Nimitz can be intense, with long hours and demanding tasks. However, the crew has access to numerous amenities, including gyms, chapels, and recreation areas, providing some respite from the rigors of life at sea. The ship's immense size allows for a variety of spaces, including aircraft hangars, workshops, medical facilities, and even a post office. There are also multiple dining areas known as galleys, which feed the crew 24 hours a day, ensuring that everyone aboard can perform their duties effectively. The original cost of the USS Nimitz at the time of its construction in the early 1970s was approximately $1 billion. Adjusted for inflation, that figure would be close to $6.5 billion in today's dollars. While the cost of building and maintaining such a vessel is immense, the return on investment is even greater. The ship has served as a critical asset for nearly 5 decades, contributing to countless operations and global missions. Beyond the initial construction cost, the upkeep of the USS Nimitz is also significant. The ship undergoes regular maintenance and overhauls, including refueling and complex overhauls for its nuclear reactors, which are necessary every 20 to 25 years. These overhauls can take several years to complete and cost upwards of $3 billion. However, these investments ensure that the carrier remains combat-ready and technologically advanced. Small arms training aboard the USS Nimitz is a critical component of maintaining the ship's overall readiness and self-defense capabilities. Although the primary focus of a nuclear-powered aircraft carrier is to project air power through its air wing, it also must be capable of defending itself from a range of threats, including close-range surface attacks, small boats, and airborne assaults. This is where small arms proficiency becomes vital. The Small Arms Gun Shoot is an exercise designed to ensure that crew members are proficient in handling a variety of personal weapons, including the M9 pistol, M16 rifle, M240 machine gun, and M500 shotgun. These weapons are used in scenarios where high-speed threats like small boats or low-flying drones must be neutralized in the proximity of the carrier. These drills are conducted periodically and are crucial for sharpening the crew's marksmanship, situational awareness, and decision-making under pressure. They typically take place on the flight deck or other designated firing areas around the carrier, such as on the fantail or sponsons, platforms that extend out from the hull. The drills may involve firing at stationary targets, floating objects, or even fast-moving drones that simulate real-world threats. This variety in training prepares the sailors for a range of scenarios that they could encounter in hostile environments. Each sailor assigned to small arms operations undergoes rigorous training in the use of these weapons, learning not just how to fire accurately, but also how to operate safely and responsibly within the confines of a ship. The drills are often performed in challenging conditions, including rough seas or night operations, where the environment adds complexity to the task. These exercises also serve a morale-boosting function, as they provide sailors with a direct and immediate way to contribute to the ship's defense. For many, participating in these live-fire exercises is a reminder of the real-world stakes of their service aboard one of the most powerful ships in the world. It reinforces the idea that, while the Nimitz projects power globally, it must also be capable of defending itself and its crew. The ability of the USS Nimitz to replenish at sea is one of the most remarkable operational features that allow it to remain at sea for extended periods without needing to return to port. This capability is known as underway replenishment, UNREP, and it involves the transfer of fuel, food, water, ammunition, and other supplies from a support ship to the carrier while both vessels are moving. A typical replenishment at sea begins with the arrival of a supply ship, often a fleet oiler or dry cargo ship, coming alongside the Nimitz. The two ships then maintain a steady course and speed, typically around 12 to 16 knots, while maintaining a distance of approximately 100 to 200 feet between them. This proximity allows for the safe transfer of materials without collision, but the operation requires precision and coordination from both crews. Once the ships are in position, fuel hoses and rigging lines are extended between the two vessels. These lines are used to send supplies over via a highline rig system, a complex set of cables, pulleys, and cranes that keep the process efficient and safe. The most common supplies transferred during these operations are fuel, both for the carrier's aircraft and for the ship itself, as well as food, spare parts, and medical supplies. These provisions are essential to maintaining the daily life and combat readiness of the crew and air wing aboard the Nimitz. During the refueling process, the carrier's jet fuel reserves are replenished. This is crucial as the aircraft aboard the Nimitz, particularly the FA-18 Hornets and Super Hornets, require large amounts of fuel to carry out their missions. The replenishment of jet fuel is a delicate task, as the carrier's tanks must be filled without any interruptions to flight operations or daily ship duties. The crew aboard the Nimitz is trained extensively to handle the complex logistics of UNREP, which often includes simultaneously managing flight operations and the replenishment process. The constant movement of aircraft, along with the need to maintain the ship's position relative to the supply vessel, adds layers of difficulty to these operations. In addition to fuel and supplies, personnel and mail can also be transferred during replenishment operations, providing the crew with much-needed communication from home and sometimes new crew members to relieve or reinforce the existing staff. Replenishing at sea allows the USS Nimitz to project power globally without the limitations imposed by port visits. Whether operating in the Middle East, the Pacific, or the Arctic, the Nimitz can stay on station for months, ensuring a continuous U.S. naval presence in key areas of interest. This capability is one of the key factors that make the Nimitz a crucial strategic asset, allowing it to maintain its operational tempo and respond quickly to crises anywhere in the world. The ammunition onload is one of the most vital operations conducted aboard the USS Nimitz, ensuring that the ship is stocked with the necessary weapons and ordnance to conduct airstrikes, defend itself, and support other naval forces. These operations are a critical part of maintaining the carrier's combat readiness and are typically conducted either at sea or in port, depending on the operational requirements. A typical ammunition onload involves the transfer of thousands of pounds of ordnance, including missiles, bombs, and smaller munitions, from supply ships or storage depots onto the carrier. These operations require a high level of coordination, safety protocols, and the use of specialized equipment to handle the delicate and dangerous cargo. When an ammunition onload is conducted at sea, it is often done in conjunction with an underway replenishment. The ammunition is transferred from a supply ship, often an ammunition ship or dry cargo ship, to the Nimitz using high-capacity cranes and rigging. Special care is taken to ensure that the weapons are handled carefully, as even minor mistakes can lead to accidents with catastrophic consequences. The process begins with the two ships maintaining a steady speed and course, similar to a fuel replenishment. Once in position, large cargo nets and cranes are used to transfer the ordnance onto the flight deck or into the hangar bay. From there, sailors and ordnance handlers carefully move the weapons to the ship's magazine, a heavily armored area below decks where the ordnance is stored until needed. The types of ordnance loaded onto the Nimitz vary depending on the mission at hand, but they typically include JDAM, Joint Direct Attack munitions, laser-guided bombs, Harpoon anti-ship missiles, and air-to-air missiles like the AM-9 Sidewinder and AM-120 AMRAAM. Additionally, smaller ammunition for the carrier's CIWs, close-in weapon system, and defensive machine guns is also loaded during these operations. Ammunition onloads are often complex, multi-day affairs that require coordination not just between the two ships, but across the entire crew of the Nimitz. Sailors from all departments play a role, from those on the flight deck operating the cranes and handling the ordnance to those in the ship's combat systems division who ensure the weapons are properly stored and accounted for. Once the ammunition is safely stowed, the Nimitz is ready to carry out any mission that requires the use of its powerful arsenal. Whether launching airstrikes in support of ground forces, engaging enemy ships, or providing air defense for a strike group, the weapons loaded during an ammunition onload are critical to the carrier's ability to fulfill its role as the centerpiece of the U.S. Navy's global power projection. In addition to the tactical importance, These operations are a clear display of the Nimitz's logistical capabilities. The ability to safely load and store a vast array of powerful weapons while at sea ensures that the Nimitz remains a formidable force capable of responding to threats anywhere in the world at any time. The careful planning, safety measures, and teamwork required to carry out an ammunition unload demonstrate the professionalism and readiness of the Nimitz crew, ensuring that the carrier remains combat-ready for any potential operation. With its rich history, advanced capabilities, and nearly 5 decades of service, the USS Nimitz remains a symbol of American naval power and resilience. Whether conducting small arms training, replenishing at sea, or loading ammunition for combat operations, the USS Nimitz continues to demonstrate why it is one of the most formidable and reliable carriers in the U.S. Navy. Thank you for joining us on this deep dive into the life, operations, and legacy of the USS Nimitz. Its story is far from over, and its contributions to global security will be remembered for generations to come.